Besides slope-intercept form, there's another very useful form of the equation of a line called point-slope form, and we're going to talk about that right now. Welcome to Math Bytes. I'm Allison, and today we're talking about the point-slope form equation of a line. Suppose that x1, y1 is a point on a line with slope m. For any other point xy on that line, the slope will be the difference in the y-coordinates over the difference in the x-coordinates. That's just from the definition of slope. Now, suppose I multiply both sides of this equation by x minus x1. What do I get? So I'll multiply both sides of my equation. Now on the left-hand side of that equation, my x minus x1 in the numerator cancels out with my x minus x1 in the denominator, and I am left with y minus y1 equals m times the quantity x minus x1. That is the point-slope form of the equation of a line, because it uses the slope m and any point on the line. So that's it. It's very straightforward. Let's do an example. Find the equation of a line in point-slope form with slope 5 that contains the point -2, 1. Okay, so our slope m is equal to 5, and our point x1, y1 is equal to -2, 1. So now all we have to do is plug those values in to our point-slope form. So our point-slope form is y minus y1 equals m times the quantity x minus x1. So let's plug in our values, and we get y minus 1 equals 5 times x minus -2. And simplifying, that gives us y minus 1 equals 5 times the quantity x plus 2. And that's it. That's the equation of the line in point-slope form. Now, suppose we wanted to turn this into slope-intercept form. Well, that just involves a little bit of algebra. Now remember, slope-intercept form is y equals mx plus b. So let's go back to our point-slope form and let's do some algebra. The first thing I'm going to do is distribute that 5 through on the right-hand side, and I get y minus 1 equals 5x plus 10. I'm just distributing my 5 through that x plus 2. Now I'm going to add 1 to both sides of the equation, and I get y minus 1 plus 1 equals 5x plus 10 plus 1, and that gives me y equals 5x plus 11. So now we have our equation in both point-slope form and slope-intercept form. Let's do another example. Find the equation of a line in point-slope form that contains the points 2, 7, and 4, 2. Okay, we don't know the slope yet, so we're going to have to find that out first before we can put our equation together. So I'm going to call x1, y1, 2, 7, and x2, y2, 4, 2. Now the slope is difference in the y-coordinates over difference in the x-coordinates, so plugging that in, I get 2 minus 7 over 4 minus 2. 2 minus 7 is -5, 4 minus 2 is 2, so my slope is -5 halves. Okay, now remember our point-slope form is y minus y1 equals m times quantity x minus x1. Okay, so I'm going to plug x1, y1, and m into my equation, and I get y minus 7 equals -5 halves times the quantity x minus 2. Now there's our equation. Now suppose at the beginning of this I had said that x1, y1 was 4, 2, and that x2, y2 was 2, 7. Then what would my equation be? Now, the slope will be the same. If you don't believe me, watch our video on slopes. And so just plugging in now, I will get y minus 2 equals -5 halves times x minus 4. Okay? So depending on what I call x1, y1 and x2, y2, these will be my answers. At the end of our last example, we got two different equations for the same line, depending on which point we called x1, y1 and which point we called x2, y2. So let's do the algebra on both these equations to turn them into slope-intercept form and see what happens. So let's start with y minus 7 equals negative 5 halves times quantity x minus 2. Okay, the first thing I'm going to do is distribute my negative 5 halves through on the right-hand side there, and I get y minus 7 equals negative 5 halves x minus 2 times negative 5 halves. That gives me y minus 7 equals negative 5 halves x plus 5. My 2's cancel out, my negative signs cancel out, and I have a plus 5. Now I'm going to add 7 to both sides of this equation, and I get y minus 7 plus 7 equals negative 5 halves x plus 5 plus 7, and that gives me y equals negative 5 halves x plus 12. So the slope-intercept form of this equation is y equals negative 5 halves x plus 12. Okay, let's go through the algebra on our other point-slope equation and see what we get. So we start with y minus 2 equals negative 5 halves times quantity x minus 4. Same thing, I'm going to distribute my negative 5 halves through, and I get y minus 2 equals negative 5 halves x minus 4 times negative 5 halves. That leaves me with y minus 2 equals negative 5 halves x plus 10. Same thing here, that 2 on the bottom makes that 4 a 2. 2 times 5 is 10. Negatives cancel out, so I get a plus 10. Now I'm going to add 2 to both sides, and I get y minus 2 plus 2 equals negative 5 halves x plus 10 plus 2. So we get y equals negative 5 halves x plus 12. It's exactly the same because it is the same line. Slope-intercept form uses the slope and one specific point, the y-intercept, to define it. But point-slope form uses the slope and any point on the line. But it is the same line, and when you turn it into slope-intercept form, you can see that you get the same equation. Point-slope form is really straightforward because all you need is the slope and any point on the line. You don't have to worry about specifically finding the y-intercept to create the equation of your line. You can use any point on the line, and then with a little bit of algebra, you can turn it into slope-intercept form. That's it for this episode of Math Bytes. If you like our videos, please subscribe to our channel. And if there's something you'd like to ask us or a topic you'd like us to discuss, send us an email. We're at contactmathbytes@gmail.com, and we will see you next time.